So now let's see the next scheduling algorithm, which is nothing but first come, first served scheduling algorithm. Okay, first come, first served scheduling algorithm. The process which has the least arrival time will be scheduled first. Okay, see, we know that, right? We have our CPU, we have the RAM, and we also have hard disk. Okay, now processes are being moved from hard disk to RAM, right? Now we will be, let us assume we are using some timer, we are noticing the time arrival time of every process. Okay, if p1 has come at some time and p2 has come at some time, we have noticed all these times. Okay, that is what we mean by arrival time. Now among all these arrival times, the process with the least arrival time, which means the process which has come first to the RAM, will be scheduled first. Okay, that is what all about first come first served scheduling algorithm. It is the simplest scheduling algorithm, right? It has some advantages, also it has some disadvantages. We'll see that a bit later. First, let's discuss this problem, okay, so that it will become even more easier to understand. Now let's draw the Gantt chart. At time unit 0, the only process which has arrived to the RAM is P1, right? P1 is the only process. And one more important point, it is a non-preemptive scheduling algorithm. Okay, it is a non-preemptive scheduling algorithm, which means whenever a process is scheduled to the CPU, until completion, that process will not be preempted. Okay, that process will be preempted only after the completion. Fine. Now P1 is the only process which is at time unit 0 in the RAM. So we have our scheduling algorithm has scheduled P1 and it will complete its execution till 4. Fine. Then we will see, let's draw the Gantt chart over here, okay, so that it will be easier to draw the table later. Time in 0, P1 is the only process. Fine, it has executed till 4. Okay, now at time unit 4, P1 has arrived, P2 has arrived, P3 has arrived and P4 has arrived. That is fine, but what is the order in which they arrive? P1 has arrived next, P2 has arrived next, right? So P2 will be scheduled next and it will go till 7. Okay, then P3 has come, so P3 will be scheduled next and it will execute till 8. Okay, then P4 has come, it will be scheduled next and P4 will execute till 10. Then P5 has come and P5 will execute till 15. Okay, see, it is a very simple algorithm, right? Nothing actually to explain. Depending on the arrival time, you can keep on scheduling the processes. Since it is non-preemptive, you will be executing the complete process in one go without preempting. Okay, that is the only point we need to notice in case of first come first served scheduling algorithm. And one more important point, it is not a priority based scheduling algorithm. Okay, it is not a priority based scheduling algorithm, right? Because we are not actually assigning any priority based on its properties. Okay, based on the property of a process, which means, for example, in case of shortest job first or SRTF, we were actually assigning priorities based on the property of a process. Okay, for example, burst time is a property of a process, whereas arrival time is not a property of a process. For example, sometimes P1 can arrive first, whereas sometimes P3 can arrive first. Okay, anything can happen. It is not the property of a process. It really will vary depending on the system environment. It really depends on the time of at the time of execution, the process arrival time will vary. Okay, so it is not a property of a process and so it is not a priority based scheduling algorithm. Okay, see, priority based scheduling algorithm will definitely have a disadvantage, which we will see it a bit later. As of now, you need to understand that first come first served is not a priority based scheduling algorithm, because we are not giving priority to any process. We are actually executing the process which has come to the RAM first. Okay, that is the basic idea, right? We are not giving any priority. Actually what we are doing is, whoever comes first, you take the CPU. Okay, rather I will not be actually giving priority to this process, saying that you should execute first or I should execute first. Whoever has come to the RAM first should execute. Okay, so it is a non priority based scheduling algorithm. Now let's see the completion time of every process. Okay, completion time. Okay, P1 has completed its execution at time unit 4. Okay, P2 has completed its execution at time unit 7. P3 has completed its execution at time unit 8. P4 has completed its execution at time unit 10, and P5 has completed its execution at time unit 15. Okay, fine. Now let's calculate turnaround time. Okay, as you all know, turnaround time is nothing but completion time minus arrival time. Okay, 4 minus 0 is 4, 7 minus 1 is 6, 8 minus 2 is 6, 10 minus 3 is 7, 15 minus 4 is 11. Okay, now we can add all 5 of them and divide by 5 so that you will get the average turnaround time. Now let's calculate the waiting time. As you all know, waiting time is nothing but turnaround time minus burst time since IO time is 0. Okay, again we are assuming that IO time of every process is 0. Fine. So 4 minus 4 is 0, 6 minus 3 is 3, 6 minus 1 is 5, 7 minus 2 is 5, 11 minus 5 is 6. Okay, turnaround time minus burst time is waiting time. Fine, 11 minus 5 is 6. Okay, now let's calculate the response time. Okay, calculate the response time of every process. As you all know, response time of every process in case of non-preemptive scheduling algorithm will be same as waiting time. Okay, so we can straight away see this and we can write this as response time. See, okay, did you get this point? Why in non-preemptive scheduling algorithm response time equal to waiting time? Because in non-preemptive scheduling algorithm, a process will wait for CPU only for the first time. Okay, only before getting the CPU for the first time, a process will wait in the RAM. Okay, once it gets the RAM, it will complete its execution. So there is no chance for waiting for that process. Okay, after that, fine.